Hey, what's going on, guys? Oscar, Cisneros, a Grease Monkey. We're working on a 2008 Dodge Sprinter van. We got some turbo underboost codes, and the truck has no power. So connected the scanner, and I had some underboost codes. And one of the codes was indicating that potentially the actuator on the turbo was defective. So I kind of have it already taken apart. Let me show you on here. So there's the turbo there, and then this is the boost actuator here. Okay. And excuse me, and then there's the connector that goes right down in there. So first thing you want to do is check power and ground. So right here where my thumb is at, that black wire, that's the 12-volt feed coming into this motor. The brown is a ground. So with the test light, make sure that that lights up from ground to this black positive, and then hook up your test light to positive on the battery. Hook it up to this ground here, and that light should light up. That verifies you got good power and good ground. Secondly, do we have control? So what I ended up doing was, we had another known good actuator, so I took that off the other turbo and I just quickly swapped it out. And with the scanner, I'm able to command it on and off. And there's a little mechanical arm here that's supposed to be moving. It was not moving prior to doing all this testing. If you have the scanner, you can do that. If you don't, it might be a little tough. So I had a known good one here. So what I did was I just took it off the other turbo, connected it, and lo and behold, I still have no movement. Okay. So the question becomes, is it possible that I have two defective actuators, or do we have a control side problem? So what I ended up doing was, again, I checked power and checked ground. It's very important. Secondly, that gray and red wire, that's the control side, that goes all the way down to the PCM over here. I disconnected that connector there and this connector, and with your voltmeter, if you have an ohm function, we ohmed those wires out. We had good continuity. I then proceeded to double check, and I load tested the circuit, because just because you have good continuity does not necessarily mean that you're going to have a good amount of current flow. So we hooked up a test light on that circuit, and it lit up perfectly. So we have a good wire, we have no cuts, no kinks, no nothing. So now the question is, do we have a bad PCM? So what I did was I back probed the control wire. Everything's hooked up now, key on, engine off. And with my voltmeter hooked up, I have 10 volts, 10.58 volts. Okay. Now, if I turn this on, see the countdown? No change in voltage, no movement. The arm hasn't moved at all. Absolutely no change. Okay. Now, what does that mean? Well, we need a good reference point. Fortunately, there are other components on this diagram, or on this system, that in essence share the same power, practically share the same ground, and I can also control it with the computer. So on the scan tool, what I'm going to do is I'm going to go back, hit continue, and we're going to go to the swirl actuator. Now when you do these tests, it wants you to have the engine running. I have found that I can do these tests with the engine at key on, engine off. The actuator should still move, and I know that because we have a fleet of these vans. We got a fleet of these vans here, and I have done it before when I've done turbo diagnostics. So that's my experience. Okay, so now this is going to be for the swirl actuator that's right in here for the intake manifolds. If you listen carefully, you're going to hear them actuate. Matter of fact, you might even be able to see them moving in there. So that confirms that you don't have to necessarily have the engine running. Now the question is, I know that's working. I know we got good power and good ground, or else that wouldn't be working. But how does the control work? So with my multimeter here, I'm going to back probe the wire, and on this one, the control feed is actually the blue and a red. And you can see that I have voltage there. I have 0.68. Now this is going to be kind of tough to do. Let's see if I can. Beautiful. Okay, cool. Sorry about that. Okay, cool. So we got 0.69 volts on the control side of the swirl actuator. That's an actuator that I can command, similar to the boost actuator. Now I'm going to start it here. Look how the voltage changed. Wow, look at that. I'm going to turn it off and on. Stop and on. So that tells me that I have good computer control to that swirl actuator. What that also tells me is that I have no computer control to my boost control. This means that after the wires have been checked, after the power and grounds have been checked, after the actuator has been swapped with a known good one, that in this case we happen to have a defective driver for the PCM. Now the way this actuator works is it constantly has power and ground with the key on, engine off. Let me repeat that. Key on, engine off. There's always 12 volts at that black and green wire. There's always ground at that the brown wire, and it's the control on the computer that determines where that actuator will move. Now, being that we're trying to directly control this actuator with the scanner and we're unable to get any type of movement, this confirms that we have a defective PCM. So what we're going to end up doing is recommending a PCM replacement, and we will go from there. I also did disconnect again these connectors, and I did a pin fit check. Pin fit looks good. Terminals on the PCM side look good, and really there's nothing else that that we can do to resolve this issue. And I'm glad that I took the time, because I was getting ready to remove this turbo, and that would have been a bad idea. Too much work for no outcome, no risk, or low reward. Too much risk. So sometimes it pays to just take your time, diagnose these things, and figure out what the heck's going on with them. I don't necessarily know why the PCM's just not working anymore. It's possible that perhaps the driver on the unit itself got damaged because a defective actuator. I have seen that happen, where it gets stuck and it just overheats the PCM. I see that with ignition coils, where it'll backfeed and it'll voltage spike and it'll cause a short in the PCM. So tough luck, guys. It is what it is. So hopefully this kind of helps out with diagnostics on some of these systems, you know. And it's funny because the Mitchell Pro Demand, the service that I use for my diagnostic service information, the OEM testing for these actuators is to check power, to check ground, and then to see if you can command it with the computer. If you got good power, if you have good ground, and you cannot get any movement, it says the turbocharger is defective and replace it. Well, that might be true in some cases, but you know, turbos are not cheap. I think on this truck they're about $1,800 to $2,500. So you know, before you make that call, you want to double check everything to make sure that everything is working the way it was designed. And prior to it too, as well, when I got here, I smoked the intake system, and turned out that we also, I'm sorry, the intercooler system, and the intercooler actually had a large leak down at the base, so we went ahead and replaced that as well with some new charge hoses. So now we just have to let them know that they're going to need a new PCM. Thanks for checking the video out. Hit the like button, hit the subscribe button, and you know, if there's any other questions you guys got with sprinters, let me know. Thanks, guys.